Have you ever wondered why Jupiter, the biggest planet in our solar system, doesn't behave like a star? This colossal celestial body, a titan among its peers, is an enigma wrapped in a mystery. Jupiter's unique features and peculiarities have fascinated scientists and space enthusiasts alike, sparking curiosity and raising countless questions. A gas giant with a magnetic personality, a storm that never ceases, and moons that could harbor life, this is Jupiter. Join us on this celestial journey as we unravel the mysteries of Jupiter from its discovery to the latest findings. The story of Jupiter begins with the ancient civilizations who first spotted it in the night sky. This celestial giant, a beacon of light, was keenly observed by our ancestors who were just beginning to understand the mysteries of the cosmos. Among the ancients, the Babylonians deserve a special mention. As early as the 2nd millennium before Christ, their meticulous records of sky observations include references to Jupiter. They called this planet Marduk, after their chief deity. Jupiter's regular motion across the sky was a testament to the order in the universe, and this fascinated them. The ancient Greeks too were captivated by Jupiter. They named it Phaethon, meaning blazing. In their pantheon of gods, Jupiter was associated with Zeus, the king of gods and men, a clear reflection of the planet's dominance in the night sky. The Romans inherited the planet's association with the king of gods, and it's their name Jupiter that we use today. For them, Jupiter was a symbol of power and authority, a celestial embodiment of their empire's might. Across the globe in China, Jupiter was known as the wood star, in accordance with their system of 5 elements. It was a symbol of growth and vitality. In India, Jupiter was identified as Guru, or Brihaspati, a spiritual teacher and advisor of gods, reflecting wisdom and knowledge. Our understanding of Jupiter, however, was limited for a long time. It was a bright spot moving across the night sky, its true nature hidden. It was Galileo Galilei who, in the early 17th century, turned his telescope towards the sky and revealed Jupiter's secrets for the first time. He discovered the 4 largest moons of Jupiter, now known as the Galilean moons, forever changing our perception of the planet and the universe. Despite its early discovery, understanding Jupiter remained a challenge for centuries. It was a celestial puzzle that continued to intrigue, a mystery that beckoned humanity to explore the vastness of our universe. When Galileo Galilei first pointed his telescope at Jupiter in 1610, he discovered more than just a bright spot in the sky. He found a world in its own right, equipped with its own set of moons. These weren't mere satellites, but celestial bodies that would reshape our understanding of the universe. Galileo's discovery of Jupiter's 4 largest moons, now known as the Galilean moons, was a revelation. Named after their discoverer, they are Io, Europa, Ganymede, and Callisto. Each of these moons is a fascinating world unto itself, with unique features and characteristics. Io, the closest to Jupiter, is the most volcanically active body in our solar system, its surface constantly reshaped by lava flows. Europa, on the other hand, is believed to have a subsurface ocean of liquid water, a tantalizing hint at the possibility of life. Ganymede is the largest moon in the solar system, even bigger than the planet Mercury. And Callisto, with its heavily cratered surface, bears the scars of the solar system's early history. This discovery was monumental. It was the first time we humans realized that celestial bodies could orbit something other than Earth, shattering the Earth-centric view of the universe. It was a profound shift in our understanding, a leap forward in our cosmic awareness. Furthermore, these moons are more than just astronomical curiosities. They're key to understanding the dynamics of our solar system. Their gravitational interactions with Jupiter give us insights into the planet's internal structure and composition. They also help us understand the forces at play in other planetary systems, aiding in our search for exoplanets orbiting distant stars. Today, these moons continue to be a focus of exploration. From the icy oceans of Europa to the volcanic plains of Io, they beckon us with their mysteries, promising new discoveries and insights. As we continue to study them, we learn not just about Jupiter, but about the workings of the universe itself. Galileo's discovery was just the tip of the iceberg as Jupiter continued to surprise us. His observations marked the beginning of a journey of discovery that continues to this day, a journey that has taken us from the Earth to the stars and beyond. One of the most distinctive features of Jupiter is its Great Red Spot, a storm that has been raging for at least 300 years. When we talk about Jupiter, it's impossible to overlook this iconic feature. The Great Red Spot was first observed in the late 17th century and has been carefully studied ever since. It's not just any storm, it's an anticyclonic storm, meaning it spins in the opposite direction to the planet's rotation. This storm is so colossal that it could swallow Earth 2 times over, with room to spare. This storm is not just notable for its size, it's also remarkable for its longevity. On Earth, storms come and go, lasting a few days, maybe a week at most. But the Great Red Spot has been swirling and churning for centuries. It's a testament to the extreme and long-lasting weather patterns that can occur on gas giants like Jupiter. The color of the Great Red Spot is another intriguing characteristic. It has a reddish hue, hence the name, but the exact shade varies over time, sometimes appearing more brick red, other times fading to a dull brown. The color is believed to be due to complex chemical reactions occurring in the storm, involving compounds like phosphorus and sulfur. But the exact process is still a mystery that scientists are working to unravel. Despite its longevity, the Great Red Spot is not permanent. In fact, it has been slowly shrinking over the past few decades. Some scientists speculate that it may disappear entirely within our lifetime, but others theorize that the storm is merely going through a cycle of contraction and expansion. So, what does the Great Red Spot tell us about Jupiter? It provides clues about the planet's atmospheric dynamics, its chemical composition, and its weather patterns. But it also raises new questions that continue to challenge and intrigue scientists. The Great Red Spot is a testament to Jupiter's dynamic and turbulent nature. It's a constant reminder of the unruly and unpredictable world that exists beyond our own, a world that continues to fascinate us with its beauty and complexity. The 1970s brought us closer to Jupiter than ever before thanks to the Voyager missions. In the late summer of 1977, NASA launched 2 unmanned spacecraft, Voyager 1 and Voyager 2. These twin robotic explorers were tasked with a grand tour of our outer solar system, with a special focus on Jupiter, the giant planet. Voyager 1 was the first to reach Jupiter, in March 1979. It returned stunning images of the planet's swirling atmosphere and its largest moons. We saw the intricate patterns of Jupiter's cloud bands, the chaotic storms that pepper its atmosphere, and the tantalizing hints of what lies beneath. Then, there were the moons. Io, the most volcanic body in our solar system, was unveiled in all its fiery glory. Europa, with its icy surface, hinted at the possibility of a subsurface ocean. Ganymede, the largest moon in the solar system, displayed a complex and varied landscape. And Callisto, the outermost of the Big Four, showed us a heavily cratered and ancient surface. But Voyager's discoveries weren't limited to visuals. The spacecraft also studied Jupiter's magnetic field, revealing it to be the strongest of any planet in the solar system. They discovered a thin ring system, composed of tiny dark particles. Voyager 2 arrived 4 months after its twin, in July of 1979. It confirmed many of Voyager 1's findings and added a few of its own. Among them was the discovery of a faint third ring around Jupiter, and the detection of lightning in the planet's atmosphere. The Voyager missions changed our understanding of Jupiter. We learned more about its composition, its atmosphere, its moons, and its magnetic field. We got a glimpse of the dynamic and complex world that is our solar system's biggest planet. The Voyager missions provided a wealth of information, but Jupiter still held many secrets. These secrets continue to draw us in, fueling our curiosity and our desire to explore the mysteries of the universe. In the late 1990s, the Galileo orbiter gave us an unprecedented look at Jupiter and its moons. Named after the famous astronomer Galileo Galilei, who discovered Jupiter's 4 largest moons, this spacecraft was a marvel of human ingenuity and curiosity. The mission of Galileo was no small feat. It was tasked with studying Jupiter's atmosphere, magnetosphere, and its moons over a span of nearly 8 years. A journey of such length and complexity came with its fair share of challenges. From a high-gain antenna that failed to fully deploy, to the intense radiation belts around Jupiter that threatened the orbiter's instruments, the Galileo mission was a testament to human resilience in the face of adversity. Despite these challenges, Galileo made some astonishing discoveries. It found evidence of volcanic activity on Io, one of Jupiter's largest moons. This was the first time active volcanoes were observed anywhere other than Earth. But perhaps the most groundbreaking discovery was the evidence of possible oceans beneath the icy surfaces of Jupiter's moons, Ganymede and Europa. Beneath Europa's icy surface, Galileo detected a magnetic field that suggested a salty liquid ocean. Similarly, on Ganymede, the orbiter found evidence of a magnetic field, suggesting it too might harbor an ocean beneath its surface. These findings revolutionized our understanding of these celestial bodies. No longer were they just frozen rocks orbiting a gas giant. They were dynamic, geologically active worlds that might even have the conditions necessary for life as we know it. The Galileo orbiter not only opened our eyes to the beauty and complexity of Jupiter and its moons, but it also sparked a new wave of curiosity. It inspired us to ask bigger, more profound questions. If these moons could harbor oceans, could they also harbor life? What other secrets do they hold? Is our understanding of the universe as vast as we think? Galileo's findings hinted at a new possibility. Could there be life in our solar system beyond Earth? In 2016, NASA's Juno spacecraft arrived at Jupiter, ready to uncover more of the planet's secrets. Juno, named after the Roman goddess who could see through clouds, was perfectly christened for its mission. Its primary goal? To peer through Jupiter's dense, cloudy atmosphere and reveal what lies beneath. Juno's journey to Jupiter was not a short one. It took 5 long years to traverse the nearly 500 million miles of space. But as they say, the best things in life are worth waiting for, and Juno was no exception. Once Juno arrived, it began its orbit around Jupiter, taking a polar path that allowed it to avoid the harshest parts of the planet's radiation belts. With every orbit, Juno dives between the planet and its intense belts of charged particle radiation, coming about 3,000 miles from the cloud tops. This daring flight path allows Juno to capture stunning, up-close images of Jupiter's clouds and probe the mysteries of its interior. And oh, the things Juno has seen and discovered. From the mesmerizing, swirling storms at Jupiter's poles to the cyclones as large as Earth, Juno has provided us with a front-row seat to a celestial spectacle. The spacecraft has also detected an overwhelming abundance of water in Jupiter's atmosphere, a finding that challenges our understanding of the planet's formation and history. But perhaps the most exciting insights from Juno's mission are related to Jupiter's magnetic field. The data collected by Juno has revealed that Jupiter's magnetic field is even stronger and more complex than we previously thought. This discovery has implications not just for our understanding of Jupiter, but for other gas giants in our solar system and beyond. Juno's mission is not yet over. The spacecraft continues to orbit Jupiter, collecting data and sending back stunning images that captivate and astound us here on Earth. With each new finding, we gain a deeper understanding of this gas giant, its unique characteristics, and its place within our solar system. Juno continues to peel back Jupiter's layers, revealing a world more complex and fascinating than we ever imagined. While we have learned much about Jupiter, many questions remain. The gas giant, with its turbulent atmosphere and intricate system of moons, continues to be a beacon of curiosity for astronomers and planetary scientists worldwide. One of the key aspects of future exploration is the planned missions to Jupiter. The European Space Agency's JUICE, short for Jupiter Icy Moons Explorer, is one such ambitious project. Set to launch in the next few years, JUICE aims to investigate the icy moons Ganymede, Callisto, and Europa, which are believed to harbor oceans beneath their icy surfaces. By studying these moons, scientists hope to uncover clues about the potential for life in these extreme environments. NASA, not to be outdone, is working on its own mission, the Europa Clipper. This spacecraft will conduct detailed reconnaissance of Jupiter's moon Europa's surface and subsurface to learn more about its ice shell and subsurface ocean. The ultimate goal? To determine the moon's potential habitability. But the intrigue doesn't stop at Jupiter's moons. Jupiter itself, with its complex atmospheric dynamics, is a subject of continued interest. Future missions may focus on deciphering the mysteries of Jupiter's atmosphere, including the longevity of its storms and the depth of its Great Red Spot. There are still many unanswered questions. Why does Jupiter have a stronger magnetic field than any other planet? What causes the distinct bands of color in its atmosphere? And what lies beneath its dense cloud cover? As we venture forward into the uncharted territories of the Jovian system, we carry with us the collective curiosity of humankind. These missions are not just about gathering data, they are about expanding our understanding of the universe and our place within it. So, as we look toward the future, we are reminded of the words of Carl Sagan, "Somewhere something incredible is waiting to be known." As we look to the future, Jupiter continues to captivate and inspire us. From ancient civilizations to modern spacecraft, our understanding of Jupiter has come a long way. This journey of knowledge and discovery has been nothing short of extraordinary, transforming our perception of the largest planet in our solar system. We began with the enigma of Jupiter, a bright point of light wandering the night sky, captivating the imagination of ancient civilizations. As they tracked its motion, they named it after the king of their gods, unaware of the colossal world they were observing. Then came the age of telescopes, and with it, the discovery of Jupiter as a giant planet, a world of gas and storms, far larger than our own. Astronomers observed its great red spot, a tempest larger than the Earth itself, endlessly churning in the Jovian atmosphere. The 20th century brought about a leap in our understanding. The Voyager missions, launched in the late 70s, gave us our first close-up views of this gas giant. The spacecraft revealed intricate details of Jupiter's atmosphere and its many moons, forever changing our perception of this distant world. The Galileo orbiter, launched in the late 20th century, spent nearly a decade studying Jupiter, diving into its atmosphere and providing unprecedented insights into its composition and structure. In the 21st century, our eyes on Jupiter have been continually updated with the latest technology. From the Hubble Space Telescope to the Juno mission, we've probed deeper into Jupiter's secrets than ever before, unveiling new mysteries and answering old questions. And the journey is far from over. The future of Jupiter exploration holds promise and excitement. With planned missions and technological advancements, we inch ever closer to understanding this colossal world and its place in our solar system. As we continue to explore the cosmos, who knows what other secrets Jupiter has in store for us? This journey of discovery is a testament to human curiosity and our unending quest to understand the universe we inhabit. Here's to the journey so far, and to the many more discoveries that lie ahead.